Iterated integrals. Start by doing a few examples. If we have iterated integral from 2 to 5 dy from 3 to 1 dx, and our function is y over x. The way we're going to look at this iterated integral is inside we have integral with respect to y, and the outside we have integral with respect to y. So the first thing we'll do, we'll integrate with respect to x, and when we integrate with respect to x, we're going to treat y as a constant. So we're going to copy integral 2 to 5 dy, and inside we integrate with respect to x, so we treat y as a constant, and I did 1 over x ln of x, and x is changing from 3 to 1. So we're firstly substituting 1 for x, then we substitute in the lower bound for x, and we're going to get ln of 1 is 0, so we're going to get negative y ln of 3, and that is expression needs to be integrated with respect to y, and limits for y is from 2 to 5. Then we're going to get negative ln of 3, y squared over 2, where y is changing from 2 to 5. So we're going to get negative ln of 3 times 25 over 2 minus ln of 3 multiplied by 2 squared over 2. Doing simple calculations, we're going to get negative 10.5 ln of 3. Another example, here we have integral 1 to 2 with respect to x, and inside we have integral 3 to 4 with respect to y, and our function is x squared minus y squared. So firstly, we look at the inside integral. So we're going to integrate with respect to y. So we keep our outer integral 1 to 2 dx, and inside we integrated with respect to y. We treat an x as a constant. So if we treat x as a constant, we're going to get x squared y minus y cubed over 3. So we're going to get integral from 1 to 2 dx, and y is changing from 3 to 4 to get integral from 1 to 2 dx, and inside we're changing y from 3 to 4. So we're going to get, substituting 4 for y, we're going to get 4x squared, 4 cubed is 64 minus 64 over 3, minus substituting the 3 for y minus 3x squared, minus give us plus, so plus 27 over 3. So that equals to integral 1 to 2, combining like terms, 4x squared minus 3x squared is x squared, combining like terms, negative 64 over 3 and positive 27 over 3 minus 37 over 3 dx. That is integral with respect to x, so x cubed over 3 minus 37 over 3x. X is changing from 1 to 2. Plugging in upper bound and lower bound, so we're going to get 8/3 minus 37 over 3 times 2 minus 1/3 plus 37 over 3. So over 3, so we have 8 minus 37 times 2 minus 1 plus 37. Doing calculations, we're going to get negative 30 over 3, so we're going to get negative 10. So integral here equals to negative 10. Here we have integral 0 to 1, integral 0 to 1 e to x plus y dx dy. Again, we'll look for an inside integral firstly. So we're going to get integral 0 to 1, antiderivative e to x plus y with respect to x is e to x plus y. X is changing from 0 to 1. The y on outside, so we're going to get e to 1 plus y minus e to y. Integral 0 to 1 dy. So we're going to get the derivative equals to e to 1 plus y minus e to y. Y is changing from 0 to 1. So substitute upper bound, we're going to get e to 2 minus e to 1 minus substitute lower bound, we're going to e to the first plus e to a 0. So we're going to get e squared minus 2e plus 1. Notice that we might have done previous example using algebra, maybe using simpler integrals, because we realize that e to x plus 1 is e to x times e to y. If we realize that, then integrals will be actually a little simpler. So antiderivative with respect to x is e to x, e to y with respect to x is a constant, x is changing from 0 to 1 dx. So we're going to get substituting 1, we're going to get e times e to y, substituting 0, we're going to get e to 0, 1, which is e to 1 times e to y, dy, integral 0 to 1. So we're going to get e to y is antiderivative first, minus e to y antiderivative second expression. Y is changing from 0 to 1. So we're going to get e times e minus e minus e plus e to a 0, which is 1. So we're going to get e squared minus 2e plus 1, exactly the same expression as we got just a few seconds ago. Comment over proposition, which I want to make, is the following. When we integrate a function of f of x, y, we do iterated integral of it, then potentially we might have integral from a to b dx and integral c to d dy. So we might have integral with respect to y inside and integral with respect to the x outside, or potentially we might switch integration and we might have integral from c to d, then integral from a to b, f of x, y, dx, dy. So potentially we might have two iterated integrals. These integrals equal as long as the given function f of x, y is continuous on rectangle AB cross CD. By that I mean, if you look at defined on that interval from when x is between a and b and y is between c and d, so on that whole interval or that whole rectangle, as long as the given function is continuous on that whole rectangle, we can switch into iterated integrals.